Why is probability essential to quantum mechanics? Imagine trying to predict the outcome of flipping a coin that never lands the same way twice. That's similar to how quantum mechanics works, but on a tiny atomic scale. Instead of certainty, it uses probability to tell us what might happen. This approach is not just a mathematical trick, it's how nature actually behaves at the smallest levels. In classical physics, if you know where a ball is and how fast it's moving, you can predict exactly where it will be in a few seconds. But in quantum mechanics, particles like electrons don't have fixed positions or speeds until you measure them. Instead, they are described by a wave function, which is like a cloud of possibilities. Each possible outcome has a certain chance or probability of happening. This is where probability becomes essential. The wave function assigns a number called a probability amplitude to each potential state. When you square this number, you get the probability density, which tells you how likely it is to find the particle in a specific place or state. The famous Born rule, developed in the 1920s, explains this link clearly. It says that the probability of an event is directly related to the square of the wave function's amplitude. What makes quantum probability so fascinating is that it's not just about our ignorance. Even if we knew everything about a particle's wave function, we still couldn't predict exactly when or where it will appear. The outcome is inherently uncertain. This shift from certainty to probability was a major change in how humans understand the universe. Numbers and probability have played a big role in human history, helping us make sense of the unknown. From ancient dice games to modern statistics, probability has been a way to manage uncertainty. Quantum mechanics takes this idea to a new level, showing that uncertainty is built into the very fabric of reality. In everyday life, probability helps us decide whether to carry an umbrella or buy insurance. In science, it helps us understand atomic particles and develop new technologies like quantum computers. These devices use the strange rules of quantum probability to perform calculations much faster than traditional computers. So, probability is not just a mathematical tool in quantum mechanics. It's the key to understanding how particles behave when we look at the tiniest parts of the universe. It turns out that at the smallest scales, the world is not fixed and predictable but full of possibilities, each with its own chance of happening. This fundamental role of probability reveals how nature itself embraces uncertainty, making it a core part of the universe's most basic laws.